This is the year 6 one, and we were talking about who was right when we had 7.32 times by 100, and we had Sam saying that it was 732, something like this, and Will said it was 732, and the reason was you add two zeros, and this was you move decimal point. Okay, so here's I guess what we can say about this. We can say that Sam is um, definitely wrong. Okay, and Will has the right answer. Okay, but their reasons can be maybe scrutinized a little bit more. So usually, if you're timesing a number by 100, you would just add two zeros. Okay, so this is why Sam added two zeros. Okay, but the problem is now the number has decimal places. Adding the two zeros doesn't take into account where the decimal places at all. Okay, so it's definitely wrong. And seven something times 100 is going to be 700 something. So it's not going to be 70,000. So Will is going to be close, and Sam is going to be far away, even if we don't know what the answer is. And then Will has definitely the right answer. You get the 700s. 3/10 times 100 is 30, and then 200ths times 100 is 2. Okay, but the reason could it's kind of a bit vague, right? It says move the decimal place. So yeah, you move the decimal place, and you get to the answer, but it doesn't necessarily explain why it happens. Okay, and so is it that we know there's a rule for dealing with multiplication by 100 with the decimal places, and we're using that rule? Okay, which is something that we could turn into an explanation. Or is it that just in this case you happen to move the decimal places? Um, so maybe the person who's asking you why this happens is thinking about why Sam is wrong. So then you might have to explain why adding the two zeros doesn't work. Okay. So there's a lot of things here. And then what is the rule? Okay. So if you multiply enough numbers out, what happens is, so I guess you have 7.32. And we know that with decimals, we can add as many zeros as we like here. And the number is the same number. Okay? And then the rule is if you multiply it by 10, okay, or any number of zeros, if you multiply by 10, you move the decimal place over by 1. Okay, so that'll give you 73.2. Okay? If you multiply it by 10 with 7 zeros or something, so we call that 10 to the 7 for short, then you'll get, so you move it 7 times now. So you go 1, 2, 3, 4, 5, 6, 7. So that'll go all the way here. Okay, with after 5 zeros. So 7, 2, 1, 2, 3, 4, 5, 0. Okay. So that's the rule when you're multiplying by 10. Okay. When you apply it to decimals. Okay. But this also works for whole numbers as well, because a whole number like 58 is really just the same as 58.000. So if you times by 100, you move the decimal twice, you get 5800. So this rule is a generalization of the rule of putting the zeros on the end of whole numbers. Okay, because it works for not only whole numbers, it also works for decimals. Okay, so you might want to try a lot of examples to see that the rule works. Okay, so if you have that, then the next task, okay, the question, the next task goes like this, okay? It says, the next task, can you prove that the rule works for any decimals? So I guess that's the rule I just talked about. Okay. What do you think might happen when you divide decimals by powers of 10? What do you think happens when you divide by 100, say? And I guess when we say powers of 10 here, we really just mean like positive powers, like 100, 1,000 divided by 10 or divided by 1,000. Okay. Is there a rule for dividing decimals by powers of 10? So is there a rule for dividing decimals by powers of 10? Okay. And the last question is, how can you check if you are right? How can you check if you are right? Okay. So that's the next task. And hopefully you can spend your hour first understanding the answers and discussion for the previous task, and then we can talk about the next task. And then hopefully we can spend the rest of that hour doing this next task. Okay? Alright, please let me know if it's something you've already done or if it's too easy or too hard.